All right, everybody, we are going to do a amine basicity exam type problem. We are charged with the task of putting the following bases in order of increasing basicity. The weakest base first, so keep that in mind. We're going to explain our choices. And regardless of what old tests said, I am going to make this now a 10-point test question. 3 points for the order and 7 points for the explanation. I believe this is a little higher than you'll see on practice exams. So when you do amine basicity, the best amines for basicity are alkyl amines. That is to say they have carbon groups attached that are not aromatic, and they're not acyl groups either. And with that in mind, I'm going to add one more molecule. I apologize. Just so you're not tempted to think amides are strong bases, I'm going to add molecule 8. I'm going to add molecule 8. And I got to make sure my methyl follows along here. And we'll just make it a simple amide. And we'll make sure we copy that over here. Adding molecule 8. Right there. And why are amides not good bases? That's a great question. You won't find that in the textbook because we don't usually deprotonate amide. So VIII is the weakest base. If you're curious, the reason why, well, we should be curious because it's part of our answer. The amide I have over there, if you put a proton on it, this resonance, which is happening all the time, it's what makes amides particularly stable. If you put a proton on the nitrogen, here's the conjugate base, conjugate acid, sorry. The amide was the base. Conjugate acid cannot resonate with the carbonyl. So that's why amides are terrible bases. Okay. And then we're going to talk about the next terrible base. Next terrible base. The aniline derivative. There's only one there's two aniline derivatives. Aniline derivatives. They're next. They're always poor bases. And you're going to talk about the same thing. Not as serious here, but resonance is lost. Same story. With aniline derivatives. Derivatives. You can't resonate with the aromatic ring if there's a proton on. So that's a, quick little story. Resonates with cannot. I don't think I have to finish that sentence. It cannot resonate with food. So we like 3 and 4 to be the next poorest bases. But I like 3 a little better than 4. We need to explain that. 3 is a little better than 4. NO2 groups in 4 destabilize NH3 plus. Well, up there it's not an NH3 plus. Here. Let's do it this way. We're looking at this molecule with NO2. And what is it? Meta, ortho, para, ortho. Destabilizes N. That N. Got a plus chart. Oops. I don't like the way I drew my NO2. On my own test, I would have lost a half point. The fact that nitrogen is plus, there's NO2 drawn out. There's the real plus. The group does not have a plus charge. I just corrected that. The group's neutral. But the N plus, very close to another N plus, is a bad situation. I hope that just goes without saying. You have an N plus here next to an N plus here. Not good story. So I don't like that as much as a molecule that doesn't have the NO2. That's all I was saying. Big story. All right, where are we at now? 3 out of 8. We're getting there. Want to go to the other end just for variety? Our best is right here. 1. And you're going to write down this. There's its conjugate acid. Has the best combination. I need to see all these words. The 2 things that stabilize cations are, there's the best combination of hyperconjugation with 2 R groups. And it's got 2 H's for hydrogen bonding. Remember, pKa reactions are done in an aqueous environment. So if you can stabilize a cation by hydrogen bonding, that's another way to help the reaction proceed. So I like 1 a little better than 2 for that reason. This is your 1 versus 2 explanation. Down here was our explanation for 7, or 8, sorry. And here was down here was our explanation of 3 versus 4. And we're 5 out of 8. What do we like better, pyridines or imidazoles? Here's a pyridine. There's only 1 pyridine and 2 imidazoles. Pyridines and imidazoles both suffer from the sp2 sp2 nitrogen destabilization of the cation. Wow, a lot of stuff. Better write it down. V, VI, and VII. V, VI, VII all would have sp2 NH plus. That's 33% S brings plus closer to nucleus. You can write that's bad, or you can go with today's society. Just put a sad face there. There you go. And that's why they are in the middle and not at the end. And VI and VII can both resonate N with N plus. That covers it. They're going to have an N plus here and here. So remember, this is the lone pair that you use for being a base. And it can resonate with a lone pair down here. These lone pairs. You don't have that with pyridine. So that puts pyridine more to the left. And sadly, this is going to be in the way of my final answer. I can make a knot in the way. And this one goes down here. This one goes down here. There you go. And lone pair resonates. Pyridine's here. It's going to go on the left side. And then we got to tell the instructor why we like VII a little better than VI. There's your final answer. Not the prettiest, but that's it right there. And the answer for why VI is a little better than VII, sorry, is a little better than VI. We have a lone pair on oxygen that can also resonate in towards the ring. And I'm going to write that right down here. VII has a lone pair on oxygen that can resonate and stabilize the N cation. I'm going to write that down here. VII has lone pair on OCH3 that can resonate towards N plus. End of story. There you go. And hopefully that's helpful. I'm pretty sure there's another video about amine basicity. Just look for that title, amine basicity. Some review from a previous semester, and you'll have more practice with that one too. I hope we have enough for you. And adios.